Hello, good morning from California, and welcome to another Add Maths or Additional Mathematics video. We are studying Cambridge IGCSE Additional Mathematics. We're into the second week and the second chapter. We're going to look today at quadratic functions in particular, and this concept called the discriminant. So some of the things that I hope to cover today are functions and their graphs again, in particular linear and quadratic functions and their shapes. The shape of a quadratic function is a parabola, and we can use the discriminant b squared minus 4ac to learn a lot about a quadratic function. We're going to talk a little bit about inequalities and problem solving and how to write solutions that are intervals on the real number line. So let's start just by looking at an easy question. If you, pretty much any Add Math student, if you got a question like this, you'd be like, yes, that's easy. Easy marks. X squared minus 4x minus 21 equals 0. You're asked to solve for x. You know that you're looking for a set of two x values. It's possible that it might be one repeated root, one x value repeated, but because it's x squared and it's a quadratic, you're generally looking for two. Of course, it's also possible that there are no x values that solve this equation, so you might get the empty set, but generally speaking, most students know, okay, we need to find two values of x, let's go find them. And of course, there are many ways to solve this. We could solve by factoring. And, pretty quickly, you'll find that x equals -3 or 7. You could solve by using the quadratic equation. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Again, of course, you'll get the same solution, x equals -3 or 7. Notice that quantity underneath the square root sign in the quadratic equation. B squared minus 4ac. That's an important quantity. It's known as the discriminant. You can see where to get the a, the b, and the c. In this case, a is 1 because the coefficient of x squared is 1. There's only one x squared there. B is -4 and c is -21. So you get 4 squared is 16 minus -84 gives you 16 plus 84 is 100. So you can use the quadratic equation to solve and get that x is either 14 over 2 or -6 over 2. And again, you get the same solution. X is -3 or 7. You could solve by completing the square. You might be explicitly asked how to do that on an exam question. Or you could solve it by graphing. You could graph the parabola. You could graph the function x squared minus 4x minus 21, and then you're going to see it has roots. It crosses the x-axis at -3 and 7. There they are, -3 and 7, and these are the solutions to where the curve equals 0, where it crosses the x-axis at x equals -3 and at x equals 7. So these are the many ways you could solve it. This is a simple question. I'm sure that all of you know how to do it. But let's look at a little bit more complicated questions, such as Pemberton exercise 2.7 number 4. And here it is. Find the set of values of k, for which the curve y equals quantity k plus 1, x squared minus 3x plus k plus 1 lies below the x-axis. The curve lies below the x-axis, and there's the curve. Now this one's a bit tricky. You can see you have a y, an x, and a k in there. You're finding the set of values for k, so this is a much more complicated question than just solve the equation. So this is the type of question that students find tricky, and I'm going to try to help you unpack it today and to learn how to solve these kinds of problems. So first, let's just look at it a little bit more carefully. We're asked to find a set of values. We don't know how big or small that set of values might be. It could be an interval on the real number line. It could be the whole set of real numbers. It could be the empty set. It could be a set of 1 or 2 or 3 values, etc. So that's a bit of a mystery, finding the set of values. And then, of course, we have to find the set of values of k, for which the curve, now let's look at this curve, y equals, in parentheses, k plus 1 times x squared minus 3x plus, well, that's interesting. K plus 1 is also grouped. Those parentheses or brackets around k plus 1, those are called grouping symbols. And for some reason, even though it's unnecessary, the question has grouped k plus 1 at the end. That's a hint that k plus 1 is going to be one quantity that we might use. And this curve lies below the x-axis. So the question is asking for a set of values. As I've said, a set of values can mean anything, any possible set of k. It could be just one value, such as k equals -3. It could be 2 values, such as k equals -3 or k equals 5. But it's more likely that when they're asking for a set of values, that it might be an interval, such as k is less than -4, or it could be an interval such as 1 is less than k is less than or equal to 5. It could be a combination of 2 intervals. It could be the whole set of real numbers. It could be the empty set. So this is one reason why students find this type of question confusing, because the set of values of k we're looking for, we're not really sure what form it might come in. It's actually most likely going to be an interval on the real number line or more than one interval on the real number line. And that is a bit confusing. Let's go on and look a little bit more carefully at this thing called the curve. This curve, which I've underlined in red, is a quadratic function in x. You can see that the y is a function of x squared, and the highest power of x is x squared. So it's a function of a coefficient times x squared minus 3 times x plus a coefficient that stands by itself. So the shape of this curve is going to be a parabola. We know that the shape of quadratic functions is a parabola, and we're asked, where does this curve lie below the x-axis? So that tells me a big hint here. It tells me that the curve must appear below the x-axis, as I've drawn there in blue, and we're looking for a set of k values that make the curve appear below the x-axis like that, which means that a must be negative because the curve is opening down, and a, as I can see, is k plus 1. So k plus 1 must be negative, and also the discriminant must be negative. So let's just talk a little bit about how we know what to do. The critical information here is that the curve lies below the x-axis. So that tells me that this question is actually about the discriminant of a quadratic function. Because I know from reading the textbook that the discriminant classifies quadratic functions into those that are below the x-axis or above the x-axis, or those that cross the x-axis, or those that touch or kiss the x-axis only once. If the discriminant is negative, that tells me that the curve must be either entirely below or entirely above the x-axis. So again, this comes from the textbook. Let's just look real carefully at the discriminant. The discriminant for a quadratic function is b squared minus 4ac, where a, b, and c are real numbers, but of course a cannot equal 0. Otherwise, there are no restrictions on a, b, and c. You can read that as A, B, C are elements of the set of real numbers. A is not equal to 0. And these coefficients of the quadratic function, A, B, and C, are what give me my discriminant. Okay, let's look a little bit more carefully at the coefficients. I can go to GeoGebra here, and you can see in GeoGebra I've set up a generic quadratic equation. I should say quadratic function. This one is y equals x squared minus 4x minus 21, or f of x equals 1x squared. So a is equal to 1. I've set up some sliders here so I can change the coefficients. A is equal to 1. B is negative 4. C, which is the y-intercept, is negative 21. Now, when A is positive, the parabola opens up. Let's see what happens if A gets a little bit more positive. The parabola becomes more squeezed or compressed or skinnier. What happens if A gets less positive? If A is less than 1, well, we see that the parabola widens. It opens up. It becomes less compressed. And what if A gets negative? Well, before that, let's look at the case where A equals 0. That's not allowed, because if A were equal to 0, it would not be a quadratic. It is a straight line. So when A is negative, look what happens. The quadratic now opens down. Not up, but down. Of course, I can change C. C, instead of being negative, I could make it positive, and C is the y-intercept, so C shifts the parabola up and down, as you can see. And I could shift B as well. Let's see what happens if I shift B. As I make B more positive, it looks to me like the parabola is moving left and right. Okay? Now this is when A is negative. If A were positive, let me make A positive again, flip it up here, A equals 1. When I shift B, now, if I make B more positive, the parabola shifts to the left. If I make B more negative, the parabola shifts to the right. And you can see how there are some values of B for which the parabola will not cross the x-axis, and some values of B where the parabola will cross the x-axis. Same can be said for C or A, right? So the values of A, B, and C affect the shape of the parabola and whether the parabola has roots, whether it crosses the x-axis. So let me change this back now to where it was before, and you can see that when I solve it by graphing, I get the roots at -3 and at 7, exactly how the quadratic equation, when it was set equal to 0, was solved using other methods. You're always going to get the same answers, x equals -3 and x equals 7. So that's a quick lesson on the discriminant and A, B, and C, and how A, B, and C affect the shape of the quadratic graph. So to summarize from the textbook, if b squared minus 4ac, the discriminant, is greater than 0, then we have two real distinct roots. The curve crosses the x-axis twice, and of course the curve can be opening up if a is greater than 0, or it can be opening down if a is less than 0. If the discriminant, b squared minus 4ac, equals 0, then the curve just touches or kisses the x-axis, and we have one root. It's a repeated root, and it means that the curve just touches the x-axis in one point. If the discriminant, b squared minus 4ac, is less than 0, then we have no real roots, and the curve is either entirely below here or above here, the x-axis. We're looking for the case where the curve is entirely below the x-axis, so that means that a is less than 0 and b squared minus 4ac must be less than 0. So now we know how to solve the problem. Let's look a little bit more carefully. Where are we going to get these values of a, b, and c? Well, you can see I have underlined them there in green, red, and blue. A is the coefficient of x squared, so a equals k plus 1. B is the coefficient of x, so b equals -3, which means that b squared equals 9. And c is the number by itself, and now we see why those grouping symbols are around k plus 1, because c is equal to k plus 1. In this case, a happens to equal c. Normally that wouldn't be the case, but here we have a case where a equals c. And b squared minus 4ac, which must be less than 0, must therefore be 9, because b squared is 9, minus 4 times k plus 1 quantity squared, because ac is k plus 1 times k plus 1, k plus 1 squared. I will add the 4 k plus 1 squared over to the right, and then read this right to left, and I get 4k plus 1 squared is greater than 9. Take the square root of both sides, and that tells me that k plus 1 must be either greater than the square root of 9 upon 4, so that's greater than 3/2, or k plus 1 can be less than -3/2. I've been told that a must be less than 0 because the curve is below the x-axis, so I choose the negative solution, and therefore I get the answer k is less than -5/2. So that, I hope, was useful to you. Thanks for watching, and good luck.